12 engineers saw your branch and origin develop have diverged after a single force push. A rebase on a shared branch rewrote commit history and broke everyone's local references. Let's break down Git branching and merging, how it works, and the exact mistake behind that failure. A Git branch is a lightweight, movable pointer to a specific commit. Creating one writes a 41-byte file, that's it. No copying of files or directories. This design makes branching instantaneous and enables teams to work in parallel without stepping on each other's toes. Merge and rebase are two ways to integrate changes. Merge creates a new commit that ties together both histories. It preserves exactly what happened. Rebase replays your commits on top of another branch, producing a clean linear sequence but rewriting commit SHAs. The critical rule: never rebase a branch that others have pulled from. Let's see this in action. Here we create a repo, make a feature branch, add a commit, then merge it back to main with a merge commit. The noFF flag forces a merge commit even when fast forward is possible, preserving the branch structure in history. Branches are cheap and easy to manage. Use git switch C to create and switch in one command. List all branches with Git Branch A and delete merged branches with Git Branch D. Consistent naming like feature enables CI/CD automation and branch protection rules. Here are the essential commands. Git switch C is the modern way to create and switch. Use Git Branch D to delete a merged branch safely. For remote branches, git push origin delete cleans up. Renaming is done with Git Branch M. A merge creates a commit with two parents, preserving the exact history of when and how work happened. It never alters existing commits, making it safe for shared branches. Use noFF to force a merge commit even when fast forward is possible. This group's feature commits together for cleaner git log first parent output. Here are 3 merge styles. Standard merge does a fast forward if possible. noFF always creates a merge commit. Squash merge collapses all feature commits into one, producing the cleanest main history but losing granularity. Rebase takes your commits and replays them on top of another branch's tip. Each commit gets a new SHA, producing a linear history. This is great for cleaning up local branches before pushing, but dangerous on shared branches because the rewritten SHAs break everyone else's references. Basic rebase replays your commits onto main. Interactive rebase lets you squash, reorder, or edit commits, perfect for cleaning up a messy local history before opening a PR. But remember, only do this on branches that haven't been pushed. Merge conflicts happen when both branches change the same lines. Git marks the file with conflict markers showing your version, the incoming version, and the common ancestor. Your job is to edit the file to produce the correct result, removing the markers. Always compile and test after resolving. Conflict resolution is a common source of bugs. When a conflict occurs, use git status to see which files are conflicted. Edit the file to resolve the conflict, then git add and git commit to complete the merge. If conflicts are too complex, git merge abort cancels the merge and restores the pre-merge state. A fast-forward merge happens when the target branch hasn't diverged. Git just moves the pointer forward. A 3-way merge creates a merge commit when both branches have new commits. Use noFF to force a merge commit for traceability and git log first parent to see only the integration timeline. Here's the difference in practice. A fast-forward just moves the pointer. noFF creates a merge commit. Git merge base shows the common ancestor used for the 3-way merge, and git log first parent gives a clean integration timeline useful for release management. 3 dominant strategies exist. Git flow uses long-lived develop and main branches with strict naming, good for scheduled releases but heavy. GitHub flow keeps it simple. Everything branches from main and deploys immediately. Trunk-based development uses very short-lived branches and feature flags used by Google, Facebook, and Netflix. Git flow in action. Features branch from develop and merge back. Releases branch from develop, get bug fixes, then merge into both main and develop. Hotfixes branch from main and merge back to both. This ensures fixes are never lost. GitHub flow. Create a feature branch from main, push, open a PR, merge, and delete. Trunk-based. very short branches, rebase onto main before merging with FF only to keep linear history, and use feature flags to hide incomplete work. Pull requests are the gate to main, not a rubber stamp. Every PR should trigger full CI, tests, linting, security scans. Senior devs approve based on logic and test coverage, not just that code compiles. Treat main as sacred. Every merge is a conscious decision. Here's a sample CI pipeline for PRs. It runs tests, linting, and a security audit. If any step fails, the PR cannot merge. This ensures that only validated code reaches main. Release branches isolate the exact code that goes to production. When ready to ship, cut a release branch from develop. All QA fixes go here. After release, merge back to both main and develop, otherwise fixes disappear. Tag the release commit for easy rollback. Here's the full release branch workflow. Cut from develop, apply hotfixes, then merge back to both main and develop. Delete the branch and tag the release. This ensures the fixes are preserved in both lines of development. This is the same issue we highlighted at the start. Here's exactly why that happened. A senior engineer ran git rebase main on the shared develop branch to linearize 8 merge commits. This rewrote all 8 commit SHAs. Then they force-pushed, replacing the remote history. 12 engineers who had pulled the old SHAs now saw divergence. 3 feature branches were orphaned because their parent commits no longer existed. A senior engineer rebased the shared develop branch and force-pushed, rewriting 8 commit SHAs and breaking every teammate's local history. The fix restores the old commit chain and adds branch protection rules. The fix involved several steps. First, the old commit chain was restored by force-pushing the pre-rebase SHA back to origin. Then each engineer ran git fetch origin and in git reset hard origin develop to align their local develop. For the 3 orphaned feature branches, git rebase onto origin develop old parent branch tip, replayed their commits on the restored develop. Finally, branch protection rules were added to prevent direct pushes to develop. This is the exact mistake from our hook. Rebasing develop rewrote all commit SHAs, then force-pushing replaced the remote history. Every teammate who had pulled the old SHAs now had a divergent local branch. The result: 3 hours of manual recovery. Using force unconditionally overwrites the remote branch. Force-with-lease is safer because it checks that your local copy of the remote is up to date. It would have rejected the push if someone else had pushed in the meantime. But even force-with-lease doesn't prevent the divergence caused by rebasing. The article uses git switch C, modern syntax, in the branch management section. This command was introduced in Git 2.23, August 2019. If your team uses an older Git version, e.g., on RHEL 7 with Git 1.8, git switch will fail. Use git checkout B as a fallback, which works on all Git versions. The article mentions recovery for orphaned feature branches, but doesn't show the concrete git rebase onto command. Here's the exact syntax to replay a feature branch that was based on a now rewritten commit onto the current develop tip. The article correctly warns against force, but mentions force-with-lease as a safer alternative. However, force-with-lease only protects against overwriting * remote changes you haven't seen. It does * not prevent the divergence problem. If you rebase a shared branch and force push, teammates who already pulled the old history will still see divergence, even with force-with-lease. The only safe approach is to never rebase shared branches at all. When you see divergence, first run git status to confirm. Then inspect the remote history with git log origin develop. If the remote is correct, align your local branch with git fetch origin and in git reset hard origin develop. If you had local commits, use git reflog to find them and cherry-pick them back. Let's run through some common interview questions. What is the difference between merge and rebase? Merge preserves commit SHAs and creates a merge commit. Rebase rewrites SHAs for a linear history. When should you never rebase? Never rebase commits that have been pushed to a shared branch. What is the purpose of NoFF? Forces a merge commit even when fast forward is possible, preserving branch structure for traceability. And a few frequently asked questions. When should I use rebase versus merge? Use rebase for local cleanup before PR. Use merge to integrate into main. What is a fast forward merge? When target branch is ancestor of source, Git just moves pointer forward. How to minimize merge conflicts. Keep branches short-lived and integrate frequently. Rebase feature branch onto main daily. Let's recap. Branches are lightweight pointers. Use them freely. Merge preserves the exact timeline. Rebase rewrites history. Never rebase a branch others have pulled. Use NoFF to keep feature groupings visible. Choose a branch strategy that fits your release cadence and keep branches short to avoid merge hell. Ready to go deeper? Up next, Git rebase versus merge, then Git stash and cherry pick, then Git workflows. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.